Okay, now recording is on. So I was saying that if there are foreign students who haven't done any Linux, then I will be here after these lectures today. And we can go through these installations together if you need. So then you can also, of course, you can install the Python 3 in Windows. And then there is this idle interface you can use to do the exercises. It's somewhere here. I have too many windows again. No, that's what was not what I was. So this is a Python shell, so you can write your commands. For example, if you want to import the NumPy, numerical Python, which you are going to need in the first exercises, then you can write the commands here in the command line, or you can write them in the file and then run with the Python command, like here in the Linux system. So you can run the commands in command line or from a file. But I think the best system to run the Python codes is the Jupyter Notebook, which you should install at least next week, but I really recommend that you install it as soon as possible. Here, this Anaconda Jupyter Notebook installs, you really should install those. And then you have available very nice Anaconda Navigator. This command prompt is where you can write the Python commands. And this Jupyter Notebook is web-based interactive computing notebook environment. And you can run the Python codes there. I can show you, I was going through your exercises that you had returned for me. So it looks like this. So here are all the returns for the first exercise I had gotten so far. So if you should save those in this Jupyter Notebook format, because as you see, it's very easy to read for me, and I can run those programs immediately. This is very nice system. I can see all those exercises at once, and I can run them here. So, but of course, the Python codes or plain Python codes or PDF documents are okay so far for the first exercise. But I strongly recommend you to learn this. It's very simple to install and use. The Anaconda system is quite large. It takes almost 500 megabytes. but hopefully you have room for it. Because later in this course, when we go to the real machine learning exercises, it's quite must to have this navigator installed. Okay, do you now have any questions about the first exercises?
I would like to ask if I can use my MacBook, so Mac OS, instead of installing some virtual machines with
Of
Ubuntu.
course, yes, of course you can use Mac also.
Okay.
It really doesn't matter what operating systems you are using as long as you can do the exercises. And I know I haven't done these in Mac, but I guess there are nice applications for Python and machine learning as well.
Okay, thank you.
So you can use either Mac, Windows, or Ubuntu. You can use those Temus servers. These shouldn't be too hard. There are some essays and some programming tasks for every week.
How do we show or return the installation exercises in Moodle?
Okay, you don't have to
Because
show me because they are not graded, so you don't have to.
So we just return it as empty.
Yes, you have to just install those, and because you need those things later. They are
okay, so Moodle allows that.
Yes, yes,
Okay.
yes, of course. It's not compulsory to do all the exercises. So you just skip those which are not graded. And they set your progress. Teemu has done those because our superiors demand it. But it's when you think of it, it's not very informative because I can see your progress when you return the exercises. So I'm not using these. Let those be here, but I can see the progress every week when I check your what you have done. Questions and coding are graded depending. It depends on the how hard they are. Some are 10 points. Some are, for example, in data analysis, programming with Python and NumPy. There are 10 exercises, so it's 10 points. And some of the programming exercises have, for example, 6 different exercises, then it's 6 points and so on. I think you can't see those. Yes. But for example, if there are 7 questions here, so it's 7 points. In general, 1 question is 1 point always. And the final grade is determined then when I sum all the points you have gotten and calculate with respect to the maximum available points. But I still have some exercises missing from the data storage section, so I can't give you the exact grading yet. Okay, question 10. Okay, those numbers 7.1, they are from another exercise number. So here is the numpy array, so you should sort them by the second row and second column. These are nothing, these 7.1 and okay, if let's do the okay. I'll edit away those.
But if I have done this exercise already, so is it okay to leave it like that? Because I submitted it on Saturday. I
Yes.
used. Okay.
Okay, what's your name?
Dmitry.
Okay. Let's see. I see. Check your answer. Oh, it's okay. I think it's okay.
Okay. Thanks.
Yes. So this number numpy array by the second row and by the second column. Okay, they can be a bit confusing, but I won't be too hard when evaluating. But I don't know how to improve it. I don't know how to improve the wording, but it's very nice that you should really criticize these exercises if they are unclear. Okay, perhaps we leave it like this, and I promise not to be too hard to evaluate. If you at least try something, then I promise to pass it. Because at least at the moment I don't know how to improve it. But just to get you started, maybe we could do the exercise 1 together. I'll use the Python idle shell. Hopefully it works. No, I have this first one is here already. Okay, I saw it here. This is one of your codes actually. I just copy pasted it because I had so hurry. We don't maybe Okay, let it be like this. So here you construct the array from values 10 to 21, stop at 22. And this is one vector here containing those values, and this reshape changes it to matrix, 3 times 4 matrix. And print the array, print the matrix. So here are the tutorials. Be careful now with Python versions. There are Python 2 and Python 3. And I just noticed today that I had a link to the Python 2 tutorial. There are some differences with these versions. So I changed that to Python 3. For example, the print command, which is the very simple one. So if we can define, for example, variable a. So Python 2 prints it like this, but Python, okay, this is Python 3, so Python 3 must have parentheses around this. Only this latter works in Python 3. So we use Python 3 in this course. So as I said, there can be still some mistakes in these exercises. And I'm very grateful if you give feedback during these lectures, or you can also send me an email or write in the Teams page. I try to correct those as they appear. Okay, let's then talk something about the theoretical things. So the literature about this data storage is this hands-on machine learning book. Hopefully everyone has been able to open it. You need our school's user access to get it. It's of course not possible to go through this whole book in this course. But we take some basic things. I think today we go these fundamentals, and I then every week I try to tell something about these topics which we are going to handle in this course. And there are questions in the data analysis section related to this book. So why this data analysis section handles mainly machine learning? That's because that's the very essential tool to analyze the Internet of Things data. As you well understand, all the devices that produce the data, there are many devices, and the amount of data is very large, and we must try to get some sense about it using these different statistical and data analysis methods. And in this data analysis part of this course, we will try to learn some basics which are useful for the Internet of Things. So many people think that when they hear this term machine learning, that it's a robot or a self-driving car. But this machine learning has been around for a very long time, and the methods it uses are very old, like regression and such things. They are very basic mathematical things. So this is quite an old thing. Some examples are for the machine learning. For example, spam filters, voice recognition, and every one of us have seen those bots in the web pages. How are you? What are you doing here? Which can't answer any questions really. They are also done by machine learning. But as we all know, they don't work very well. There are some descriptions of machine learning here. I think that this first one is my favorite. Machine learning is science of programming computers so that they can learn from data. That is the main thing. They get the data and then they learn from it. I don't understand this Tom Mitchell's explanation at all. So why use machine learning? Let's first consider this traditional spam filter thing. And you get mail and then you decide that this is spam and you write some spam filter rule that if, for example, if the subject line contains these words, then it must be spam. But of course the spammers get smarter and smarter and they change those subject lines, and you must be all the time, you have to be updating those magic words. But when you are using machine learning techniques, then this algorithm learns from the data without that you don't have to be involved in every step. So machine learning automatically learns which words and phrases are good predictors of spam by detecting unusually frequent patterns of words in the spam examples. So the program is shorter and easier to maintain. And it can even automate it further. So the machine learning system learns from the new data. When new data comes, the training algorithm is updated, which improves the result all the time at least to some point. Of course, it's not improved indefinitely. Okay, I'm not going through all the materials here, just some points. Okay, here are some examples of applications. Image analysis, for example, in medicine, nowadays they can diagnose, for example, cancer from MRI images using these neural network algorithms. And for example, skin cancer can be, at least at certain situations, it can be detected from the surface of the skin or from the heat camera images and such things. And of course, then traffic control cameras use machine learning and such and so on. Okay, there is the detecting tumors. It was there. Flagging offensive comments on discussion forums. This doesn't work for Donald Trump, of course, but for other people, normal people. Okay, here is a chatbot or personal assistant. Different forecasting, weather, company revenue, and such things. Nowadays, there are many applications that react to voice commands. I got a new car last week and was a little bit surprised that it could recognize my voice and understood the address I gave it. But personally, I don't like these voice recognition systems very much, but some people may like those. Okay, there are many applications. Something about the types of machine learning. The basic two types are supervised and unsupervised. If it's supervised, then the programmer must train the system. If it's unsupervised, then the system learns by itself. And then there is of course, systems that are in between, like semi-supervised. When we talk about supervised learning, then we have some kind of training set. We have right labels and wrong labels. And we train the system to recognize those. And then we have another set independent of these, so-called test set, that we can test the system, how well it classifies those. For example, right or wrong. This can be the spam filter, whether those messages are good or not. This is quite simple. You have only two possibilities, but it can be also very much more complicated. Another typical task is to predict a target numeric value, such as price of a car, given a set of features by its brand, which are called predictors. And this task is called regression. And in this case, we need very many cars, of course, with different predictors. And in general, the regression looks like this. You have some data, and then you fit some kind of mathematical function to this data that best describes it. In the simplest case, it can be linear, so it's quite easy. But for example, in this case, it's obviously not linear, but some kind of higher degree polynomial, for example. And when you have the mathematical function, then you can interpolate the value. If you have, for example, if you know some feature here in x-axis, and then you have the mathematical formula, then you can, of course, calculate the value in this y-axis. Or you can extrapolate if you have data outside of this range, so you can predict what it will be. Here are some of the most important supervised learning algorithms. We will go through some of those in this course, but I guess not everything. Linear regression is the simplest. I think everyone knows what it is. It's what Excel does, for example, when you fit a line to the data points. Logistic regression, k nearest neighbors. I don't think we go with those SVMs or decision trees. I don't know exactly. Maybe we can. Maybe we have time. Then there is supervised learning. So we don't have any labels, but the system tries to learn without a teacher. So the system has no a priori knowledge of this. We see some examples later. This can be clustering. So for example, here, the human eye easily catches 4 different groups in this training set. And the clustering means that the program finds these groups automatically. Anomaly detection and novelty detection means that you have some value that is very different from the previous values, so-called outlier. Dimensionality reduction. Okay, I'm not going to try to explain the PCA. I have used it in the past quite a lot. But let's keep it for now. Let's see the clustering, however. So here you see the 4 groups I was talking about. For example, say you have a lot of data about your blog's visitors and you may want to run a clustering algorithm to try to detect groups of similar visitors. At no point you tell the algorithm which group a visitor belongs to. So it finds those connections without your help. For example, it might notice that 40% of your visitors are males who love comic books and generally read your blog, while 20% are young sci-fi lovers who visit during weekends. and so on. Visualization algorithms, you feed them a lot of complex and unlabeled data and they output a 2D or 3D representation of your data. I guess I have seen these kind of visualizations, for example, in Finnish politics, where, for example, political candidates are visualized according to their opinions. For example, here you see many different things color coded. There's cat, quite outside, then dog is this violet, deer is red, horse is blue, so on. Okay, here is the anomaly detection. Of course, the anomaly is outside of these normal values. And the semi-supervised is that you just give a few classes or a few labels and then which helps this classification, since the labeling is time consuming. So you have plenty of unlabeled instances and only a few labeled ones. This reinforcement learning is quite like trial and error. So here's, for example, a robot that learns from its mistakes. Don't go that direction. Then it must have a learning step, so it updates its policy. That maybe it would be wiser to go to the other direction. Another criterion to classify machine learning systems is it either batch or online. In brief, batch learning means that you have all the data available at once and it doesn't change. This is also called offline learning. And if you want this batch learning system to know about new data, you have to train a new version from the scratch using the full data set. Not just the new data, but also the old. Online learning means that you get the data all the time as it comes, and it is added to the system. And these data groups are called mini batches. So you may have a large data set and then you add these mini batches one by one, new data on the fly. So many industrial systems, of course, use these. You have some stuff going very fast in some pipe or something, and this system must evaluate its quality, for example, or stock prices. Then instant versus model-based learning. Instance-based learning means that the system tries to the system learns the examples by heart and generalizes. For example, in this figure, the new instance here would be classified as triangle because the majority of the most similar instances belong to this class. There are more triangles in the near this new instance than there is only one square, two triangles. So it uses some similarity measure. In this case, the similarity measure is the number of instances in the near this new instance. And then model-based learning, it uses some mathematical model to make predictions. It's like the regression, but in more general situation. Okay, here is a concrete example. Does money make people happier? Here is the grand national product, or what is it? Gross domestic product and life satisfaction. As you see, United States has the most rich country, richer than Hungary here. So at least in this picture, it seems like it really goes like this: that if you are rich, then you are happier. Life satisfaction is. Okay, yes. Poor people didn't have access to vote in the US. It will be very interesting to see what happens there in the presidential election. If Trump loses, what happens? He just says it was the result is cheated and won't go anywhere. Okay, it's quite easy to think that there is a trend. So now we can select a linear model. No, okay, everyone knows what a linear model means, hopefully. Is this line equation. Life satisfaction is the y-axis and GDP is the x-axis, and you have some constant and a slope times the x-axis gives the value of the y-axis. And you can calculate this theta 0 and theta 1 analytically. So what this should be so that this blue line goes based through all these data points. In other words, what these parameters should be so that the least squares error between the line and these observations is minimized. Here are some examples. If you put the constant value to 0, then this line is nowhere near these observations. And for example, here constant is 8 and the slope is negative, so it doesn't represent the data very well. And this function that measures how good your model is, you either maximize or minimize some value. This utility function measures how good your model is, and a cost function describes how bad it is. And in linear regression, we use this const function, which is calculated so that you calculate the difference between each data points and this line, and square the difference and sum all the differences together. And those values for theta 0 and theta 1 that minimize this sum is the best fit. Okay, this is now the model. The model is fitted to the training data. Here, here's an example code using the scikit-learn. Okay, we haven't done those yet, but we are going in that direction. But in general, you first have to study the data, and in this case we saw that it may be linear, and when we saw that it's linear, then we selected a linear model, which is the first degree polynomial. I think every one of us knows that much mathematics, even though you are programmers. And then you train the model. In this case, it can be even calculated analytically by derivating, but I'm not going through that one. And find the parameters so that it minimizes the cost function. And then we can apply it to new cases. For example, if we want to estimate some country with very low GDP, then we can estimate what their life satisfaction will be. Let's see. Okay, here we see the problem of this model. The data we saw in the previous example didn't contain all the data. There are, for example, there are countries like Norway, Switzerland, and Luxembourg, which have much higher GDP than in the previous big image. And if you add these points, and here Brazil, Mexico, Chile, Czech Republic, these reds are new data points here. So we notice that this dotted line here, which was the original line according to this original data set, it's not correct. So now you see that if you don't have all the data or you have imperfect data, your model can be wrong. So taking into account this new country is the solid line now, gives a better fit to the observations. So only a few missing countries significantly alter the model, which are these 3 countries here. And maybe this is also clear that such a simple model is never going to work. So according to this original prediction, these very rich countries should have they should be very happy people living there, but that's not the case. For example, Luxembourg is lower than Brazil and Mexico. So it seems quite so that there is no correlation between GDP and life satisfaction, since this solid line is going closer and closer to the straight line with no slope. That means that there is no correlation between these two parameters. If it's just a line with only a constant value and no slope in either direction. Okay, time is running, and I'm not going through all of these things. Maybe a few words of this overfitting, which occurs in many cases in these machine learning things. This is an example of model that has too many degrees of freedom, meaning it's too high degree polynomial. So it doesn't follow the trend. If you look at the data points, it would be, for example, very shallow second degree polynomial, like a parabola. But when you give the model freedom, too much freedom, then it goes through every data point, which is nothing, it has nothing to do with the real world. It follows the noise. And that's called overfitting. So obviously you should take away some degrees of freedom, or for example, in this case, I would fit a second degree polynomial to this data. Sometimes it is really hard to see this overfitting, but we have some methods we learn later what to do with these. It's not always that obvious, like in this example. So overfitting happens when the model is too complex relative to amount and noisiness of the training data. Here are the possible solutions. Simplify the model, gather more data, reduce the noise. You can see everything those in here. So the noise means that in this starting values in this left section, there is quite a lot of noise. And here is too little data, only a few points in this right part. And the model has too many degrees of freedom. Underfitting is the opposite of overfitting, and then your model is too simple to learn the underlying structure of the data. For example, if you go to this image here, so the linear model probably is an underfit. it doesn't fit very well in this dataset. Anyway, you try to look at it. And in this case, you should select a more powerful model, meaning in this example, you should have at least a second degree polynomial. Fit better features. I guess that means that you must have better data, more data points, less noise. The constraints of the model means that the constraints means that you can limit the parameters to certain range. For example, you can't get the slope or constant in this have any values. Here the regularization means that it forces the model to have the slope in some range of values. It's really some kind of wow term, regularization hyperparameter. Seems really nice, but it's nothing more special than that you just limit the values to certain range. Okay, that's about it. What I was going to talk about today. Maybe you got some understanding of the machine learning, and we shall continue next Wednesday. I will go through your exercises, what you have returned so far, and give you the points and maybe comment if I have anything to say. And next week we will I'm not that harsh usually. For me, the most important thing is that you try at least for the programming exercises. If the answer is a bit off, then since the grading is 0 or 1 point, I usually give the 1 point if there is some if I see that the student has tried its best. For the essays, I expect that there are more than a few words. You don't have to write several pages per question, but a few lines at least of text. So you can't answer in just a few words in those questions, but you don't have to write everything you know. Just try to use some common sense. So next week we have some statistics and machine learning basics. I think these machine learning basics are things that I talked about today, and some Python programming exercises, and the Anaconda and Jupyter Notebook installation is for next week. And then week 3 we go deeper into data analysis. Pandas is another Python library used for machine learning. and then we have quite a lot of doing in week 3. We have these 2 exercises, and week 4 we have this whole machine learning project. And for these exercises from week 4 onwards, you need at least at that point, you need the machine learning notebooks. In this link, in this GitHub link, there are all the exercises used in the book. When you install the Anaconda and Jupyter notebook, you can run all the exercises from here, which is really nice. I have learned myself very much running these. Since the Jupyter notebook is really nice that you can run the codes directly here and see every step what happens. Okay, I think that's it all what I'm going to say today. And really sorry about the Teams mess. We'll use this Zoom from this week on. If you don't have anything else, then we stop here. I will send this link to this course Teams page. And I think I also put it in the Moodle page somewhere here. So it should be possible to look at those. Okay, if there's nothing, then the opening of the applied university starts at 1 o'clock. So please go there. Okay, see you next